Today we're going to be covering messaging options for big data, covering technologies of Kafka, Logstash, and Fluentd, concentrating on real-time handling of Apache logs. After a brief overview of the project, we will go into specific goals, identify problem statements, present background of the three technologies, followed by a demo, findings, summary, complete with benefits and issues, and finally a retrospective analysis. But first, there are two types of messaging options, queued or publish subscriber. There are a number of vendors within the marketplace that are equipped to provide meaningful data from messaging options, but their capabilities vary on their fundamental design. The goal of this project is to gain an understanding of how Kafka, Logstash, and Fluentd can be leveraged to provide useful insights into the data that messages may contain. There are two overall problems that we kind of want to look at. How can Kafka, Logstash, and Fluentd handle extracting valuable information from real-time data streams? But in particular, how they can extract geolocation, response code of the server, and the number of bytes transferred from access logs. Before diving into the demo, here's a brief overview of the technologies. Kafka, known as Apache Kafka, is an open source Apache project that was developed at LinkedIn. Its primary use is to act as a message broker between a producer and consumer. Logstash is also an open source project, but its primary use is slightly different from that of Kafka, as it is focused on managing logs. Similar to Logstash, Fluentd is an open source project, but also offers proprietary enterprise services. Additionally, it is widely utilized within the Amazon ecosystem. Now to the demo. I'll be showing how Kafka has a producer and a consumer, but how I set this up is in a very unique way where Fluentd and Logstash are actually set up as consumers of the Kafka topic that we create. So let's go into it. Alright, now to the demo. So in the demo, I have a Kafka instance. As you can see here, a Fluentd instance here, as you can see from the configuration. And finally, I have a Logstash and Elasticsearch. Also on the Fluentd, I do have Elasticsearch installed as well. So let's go over it. So each of these servers is living on its own EC2 Amazon Web Service instance. So let's go ahead and get Kafka started. So Kafka, we're going to cd into the Kafka home directory, and we're going to go ahead and start the Zookeeper. The Zookeeper needs to be started before we can go ahead and start the Kafka server. Again, we're going to need to cd into the Kafka home directory. Start this server. So now that we have Kafka running, we can go ahead and start Logstash and Fluentd, which both are set up to be consumers of the Logstash of Kafka's are both set up to be Kafka consumers. So first, let's check the topics that are on our Kafka machine. You can do that by cding into the Kafka home directory and running this command. You can see here that I have a topic of test. The group is also important, and that's in a configuration file in the Kafka home directory. So now that we're ready to set up our consumers, let's take a look at our consumers. So first, we're on Fluentd. We're going to go ahead and start our Elasticsearch. We're running the symbol command. And before we start Fluentd, let's take a look at its configuration. So as you can see, I created a directory called Fluentd config. This is for ease of use, and if you start to have a lot of configuration files for Fluentd, or even Logstash. It's nice to have. So as you can see, we're going to be tailing this file. We also have a position file. We're going to be doing a custom regex here. There are a lot of built-in regexes, such as Apache 2, that is the type of log that we will be parsing, is an Apache 2 access log. But it doesn't, sometimes get all the information we want. This op right here actually is the query string of a request. So anything that comes after the question mark in a request will be parsed out as well, and found that can be pretty helpful when trying to diagnose possible issues or anything like that. Also, here we're going to be setting up the GeoIP. Notice that we're wrapping this in record. Depending on the documentation, you could possibly see no record tags here. It is important to have the record tags there. Finally, we're going to be storing this output into multiple different storage systems. So we're just going to be sending it to standard out so we can kind of see it. We're also going to be sending it to a log file, a gzip log file, and then finally we're going to be sending it to Elasticsearch. So let's go ahead and start our Fluentd configuration. Now that that's started, now we're on Logstash, so we're going to go ahead and get Logstash started, or Elasticsearch started on our Logstash machine. As we did on the Fluentd, we started Elasticsearch first. So as you can see here, again, I have a custom configuration that I created. So we're going to cd into Logstash, and then we're going to vi into Logstash, vi config, Logstash custom configuration. And as you can see here, this is able to read from standard input. We're going to also be reading from this file. And once again, we have a common Apache log, but I still want to get the query parameter, so I want to do something a little bit different here. We also have a date format for our timestamp. We're also going to get the geolocation, and if we have a user agent, say this is not just an access log, but has more of an extended log that has Apache, that records the user agent in the Apache logs, you can parse that as well, and you'll get operating system as well as browser. So here are where we're going to send it out. We're going to send it again to standard output. We're also going to send it to Elasticsearch. And we're also going to send any response code that starts with a 4. So say 404s, for example. You can do 500 errors. And actually, we're going to send this to a file. So this could be especially useful for 500 errors if you then write a monitoring script that will monitor this output file. So let's go ahead and start this Logstash configuration. All right. So next, let's take a look at the script that we're going to run. So this is the consumer script that I set up. This is important right here. This IP address corresponds to the IP address of my Kafka machine. Just remember to note that I am working on 3 different servers here. So here's the IP address, this group that was specified in the Kafka configuration, and the topic that you saw. We're going to be opening up this file. We're then going to be writing to this file. And then finally, we're going to print it also to the standard output so we can kind of see what's going on. So let's go ahead and start this consumer. So it's complaining that this file doesn't exist. So what I'm going to do, I'm going to cd into here. I'm going to touch, I'm going to grab this just to instantiate the file. All right, cd back, Python consumer, and now it shouldn't error on me. All right, so now let's get the Fluentd set up as well. So let's see here, we cd into Python, Kafka, and then we're going to start Python consumer. Oh, see, I did not create this yet either, so cd into there, touch. Let's go ahead and create that. So now that that's there, let's cd back. I'm going to start this consumer. All right, now the consumers are listening on that Kafka topic. Now we're ready to start the producer. So let's take a look at the producer. So here you can see that we're going to be reading from this small file. This file is about 500 lines. For the sake of this demo, I kept it a little bit smaller. You know, most Apache logs read written to all the time. And we're going to be writing to this every half second to kind of simulate a real-time Apache log being written to. So let's go take a look at these logs real quick, see what we're actually going to be writing to, or writing out of. So as you can see, we're about 500 lines here, and for the bigger one, we're about 1.9 million lines. So that would take a little bit longer if we're waiting half a second. You know, that is a month's worth of data from NASA logs that were publicly accessible online. They were from 1995, so they are a little bit interesting to kind of see. All right, so let's go ahead and start our producer. And let's double check. Consumers are listening. Elasticsearch and Logstash and Fluentd are up. All right, as you can see, it's starting to write to this topic, and they're starting to be sent and listened to on the consumer. And you can see over here as well that the consumer is also being listened to. So let's take a look and see what our Elasticsearch count is. As you can see, Kafka or Fluentd is, or this is Logstash. Logstash is running into some errors. This is actually normal for this. These logs are actually being parsed. This is one of the confusing parts of Logstash, is that this plugin, even though this shows that it is a level error, it is still being parsed, but it's only because the geolocation cannot be found for a particular IP address. So if we do a count, it's 75 here, and I would imagine that if we're on Fluentd, so we're just a little bit more. If I go over here, you know, 99. So we're about even. You know, these will parse the 500, and they'll be aggregating. Some of the cool things about Elasticsearch and these two machines, these two technologies, is that you can do a search on response. I'm going to do response here. Response of 200. And we're going to pretty, so it did not find anything. Oh, helps if I spell this correctly. So as you can see, it does return some response codes. Let's see how many there are so far in this. You can do that simply by saying count. And there are 200 current response codes out of 226 requests. So that's pretty good. Let's take a look at some other information. Such as, let's see here, state, I believe, is in here. City, LA, maybe? Nope. So let's do, as you can see here, this has country, longitude, latitude, This one doesn't have a state, as you can tell. Some of these IP addresses are pretty old, so they're not going to have too much valuable information for a geolocation, but that happens all the time. You can see time zone here. We're in, this is Canada. Let's see how many Canadian IP addresses have come in. Once again, it does help if you can spell correctly. As you can see, there's 18. So let's take this and let's go over to our Fluentd. Let's see how many this has. As you can see, it's 18 again. And let's go grab one other useful one. So let's see how many response codes, but let's see how many response codes are 404s. Well, actually, you can see that response is what Logstash spits out. But in Fluentd, as you can see over here, code is what the response code is. And there's one. See how many 200s we have? 440, maybe some 300s, 303s. Let's one last time, maybe 500s. Nope. All right. Well, as you can see, the producer has finished. The producer, can keep writing as long as it, needs to Kafka and run this in batch. As long as these consumers are listening, they are going to read these and put them into Elasticsearch. So that way you can, monitor traffic via these Apache logs. And that's it for the demo. Hopefully you've seen how each of these handles messages. Unfortunately, Kafka, it does have Elasticsearch plugin, but it does not appear to be compatible with this current version of Kafka. Hopefully in the future, Kafka will be able to gain this Elasticsearch plugin, at least for these newer ones, and maybe wider compatibility. Kafka is still, in its infancy, and a lot of the plugins are starting to pop up for Kafka. Fluentd and Logstash, like I said before, have a large number of plugins that are, pretty accessible to you. So, all right. So I hope all of you enjoyed that demo. I had a great time, investigating and discovering these technologies. Kafka, lacked plugin support that could not isolate the geolocation, and as I mentioned before, I wish that the Elasticsearch Kafka plugin was a little bit easier to understand and able to install. But Kafka, being in its infancy, has plenty of room to grow, and I look forward to possibly using Kafka in the future. Logstash was my favorite. It was able to successfully parse in real time the relevant data, including 404s, geolocation, bytes transferred, and trending user traffic. Specifically 404s, I liked how it was able to send particular 404s to an external file. Fluentd was also able to successfully parse in real time the relevant data, including the geolocation, bytes transferred, and the trending user traffic. In summation, each of these technologies can handle messages effectively and efficiently. So the ideal choice for a potential customer or user would vary based on the requirements. For the scope of my project, like I said, Logstash is more favorable due to its completeness as a solution that provided flexibility. Logstash, however, was not without fault, as I did run into errors generated by the plugin that did nothing more than cause confusion. as I did mention in the demo. Kafka and Fluentd are worth looking into due to the high throughput, low latency potential, and lightweight, smaller data footprint. Looking back, overall, each of these systems in their own unique way were able to broker messages from point A to point B, and the multitude of plugins greatly attributed to the success or the lack thereof of these systems. All three systems have reasonable speed, efficiency, and are fault tolerant. In particular, I was able to abstract data for geolocation, and I was able to gain insightful information about response codes of these requests.